Yes, that part. That's the one. Okay. We'll fill this out together. All right, we did hydrogen yesterday. Most of the answers are 1. So we'll pick up with silver. Okay? For silver, what is the symbol? Hannah? Good. Capital A, lowercase g. The atomic number? Anna? 47. Very good. The atomic mass? Connor? 107.87. Do you remember the unit? AU, which stands for atomic units. Good. I'll go ahead and tell you, I was looking over my key from last year, and we wrote the units as AMU, which just means atomic mass units, just so you know. Okay? Group number for silver. Trinity? 11. Period number. Reagan? 5. Number of electrons. Total. Connor? 47. Number of shells. Ethan A? 5. It's the same as the period number. And then valence electrons. Now, hold on. Yesterday, I told many of you to start at the noble gases and then count backwards, right? So you would have gotten 11 valence electrons. I was wrong. After number 20, after calcium, where we stopped, right, with our diagrams and such, when the rules get different, the valence electrons don't follow that. Technically, silver has 1 valence electron, okay, which does not follow the pattern at all. So we're going to go ahead and cross off. I was wrong. So we're going to, not all of them, but that one we are going to cross off. We'll cross off some of them. But I'll show you what I mean. Just cross off that one for now. Okay, but see here, if you look at the diagram for silver, okay, it has 1 electron in the outer shell. So technically it has 1 valence electron, which does not follow the pattern at all. Okay, so we'll cross off a few of them, and then some of them we will fill out anyway. So, yes.
So for what I did is I just, for the valence electrons, I just put the same number as the group number.
Yes, and with the way that I told you, that would have made sense, but I was wrong. So you can't do that, actually. Okay? All right, symbol. The symbol for radon. Connor?
It's RN also.
Capital R.
Capital R, lowercase a.
Okay.
And the way you can, whenever I put number of shells, that's the period number.
Yes.
And when you put atomic number, that's how many electrons.
Yes.
It's just number.
All right, atomic number. We gotta go a little faster here. Kayla. Radon, atomic number. 86. Which means it has 86 what, class? Protons. Good. Atomic mass for radon. Ashley? Good. 222 atomic units. Group number. Caleb. 18. We need some noble gas. Period number. Nathan? 6. Number of electrons total. Noah? 86. Number of shells. Parker? 6. Good. The period number and the shells numbers should be the same. And then this one, we actually are going to fill out the valence electrons. Because it's a noble gas, how many valence electrons will it have, class? 0. Good. All the shells are full, so it will have 0 valence electrons. All the noble gases have all full shells and therefore 0 valence electrons. Germanium, the symbol. Nico. Capital G. Capital, well, not capital G, capital E. Capital G. Good. Capital G, lowercase e. Atomic number, Landon? Yes. Atomic mass, Ethan H. Good. 72.59 atomic units. Group number. We're not called on yet. Sophie? Okay, find the symbol, capital G, lowercase e. And then tell me the group number. That's the atomic number. What's the group number? I'm sorry? 14. Yep, that's correct. Period number. Reagan? 4. Number of electrons total. Landon? Good. Number of shells, class? 4. Good. They should be the same as the period. And then mark off valence electrons because that is after the part where the rules change. And titanium. What's the symbol for titanium? You have to sing it when you say it. Parker?
It is
Capital
capital T, lowercase I.
T, lowercase I. Atomic number. Ethan A? Yep. 22. Atomic mass. Trinity. 47.908. Good. 47.90 atomic units. Group number. Caleb? Group number? Oh, 4. Good. Period number. Anna? 4. Very good. Number of electrons total. Ashley? 22. Number of shells. Bella? 4. And then again, mark off valence electrons because the rules change after 20. Okay? Yes. Yes, write the symbol for the following elements. Connor, symbol for nitrogen? Capital N. Magnesium. Nathan?
Capital N, lowercase.
Good. Gold. Nico? Good. Well, guys, give me the capital. Good. Capital A, lowercase u. And rubidium. Hannah? Capital R, lowercase b. Good. All right, going on to the next page. Atomic mass. We know that all the units are going to be AU, so I'm going to just go ahead and fill those in. Aluminum. What's atomic mass for aluminum? Parker?
26.98.
Good. 26.98. Phosphorus. Ethan H? 30.97. Question? You mean the atomic number plus the atomic number?
Well, no, because 1 times 1 is 7.
Right. 7 times 7 would give you 49.
Yes.
So you mean 7 plus 7?
Yes.
Yes. And the reason why is typically, until you get into like the much bigger elements, the number of protons should be about equal to the number of neutrons. So if you have 26 protons or 7 protons, you'll have 7 neutrons, and therefore the mass will be around 14. Yes.
But for helium, it's 1.00794.
Correct.
That's like 200.
But
that's 200 off.
Right, but no, it's not. No. But no. Hydrogen has 1 proton and 1 proton only.
Oh, it's missing the
Otherwise, it would be 2. Okay, chlorine, atomic mass. Landon. Good. 35.45. And neon. Ashley? 20.18. And neon. Sophie? Or helium, sorry. Atomic mass. That's hydrogen. Well, she has a whole table in her notes. She's got a whole table in her notes. Anna? Thank you. 4.00. Okay. For the essay, okay? The essay is worth 10 points, and this is why. You need to list and describe the 5 parts of an atom. Okay? Write your answer in complete sentences. So, with questions like this, where you have to do 2 things, list and describe. Okay? And you have 5 parts. That's 10 things you have to do to get all 10 points. Okay? So, with longer questions like this, sometimes as you're writing and you get going, you think you mentioned one, but you forgot it. Or you kind of get going and you mention one twice on accident. Okay? So we're going to do it this way with a method to that you could use to help make sure you hit all the points. Okay? So someone name for me the 5 parts of an atom. Bella? Protons, neutrons, electrons, nucleus, and shell. Now, I'm going to go through these in order, and we're going to name and describe them. Every time that I name it and describe it, I'm going to give it 2 check marks. One for listing it and one for describing it. That way I know I've hit all 10. Does that make sense? Yeah. All right. Someone name and describe for me the proton. Connor.
A proton is a positively charged atom in the nucleus.
Okay, it's a positively charged particle, not an atom.
Particle in the nucleus.
Good. So you're writing what I'm writing. A positively charged particle in the nucleus. Okay? So I named it and I described it. So I'm going to get 2 check marks. Yes.
Are we on the test? Are we doing it exactly like this? Because I feel like I probably would have put like nucleus first and then.
No. Yeah, it doesn't matter what order.
Neutrons, and electrons because they're kind of on there, and then we do the shell.
Yeah. No, doesn't matter. However you want, whatever order you want to do it is fine.
But on here we're doing this one.
Do it the way I'm doing it now. I don't want you to see this. Okay. Nico, you want to do neutrons? Okay. Okay.
Neutron is a particle in the nucleus that has no charge.
Perfect. A neutron is a particle in the nucleus that has no charge. Or you could say that it is a neutral particle, or it's a particle that is electrically neutral. Okay? Named it and described it. And the nucleus has no charge. So 2 check marks. Give you a chance to catch up.
What does the nucleus do?
The neutron?
Yeah.
It doesn't do anything. The only thing it does is add weight or mass to the atom. Does that make sense? So, for example, if you have nitrogen, okay, and you have 5 protons, 5 neutrons, as you add more neutrons, nothing changes with the charge of it. It just gets heavier and heavier and heavier. And sometimes if the atom is heavier, it can behave in different ways. That's all it does. Okay? question. All right, electron. Sophie.
An electron is a negatively charged particle that spins around the shell.
Good. An electron is a negatively charged particle that spins around the shell. You can say that too, sure. Okay, we named it electron and described it. Negatively charged particle. So 2 check marks there. So far we've got 6 of the 10 points. Okay, Kayla, do the nucleus for me, please. Good. And where is it with the atom? Good. The nucleus is where the protons and neutrons are. In the middle of the atom. So we named it and described it. Question? Or you want to do the next one? Okay.
Is it okay if I didn't say exactly what you said, or is that something like it?
Yeah. You have protons and neutrons in the middle? Or in the center?
For the nucleus. I said the nucleus houses the protons and neutrons in the middle of the atom.
Yep. And Parker, the shell.
So the shell is an energy level. Well, it is in energy levels, and it contains the electrons that are spinning around inside of it.
Around what?
Around the nucleus.
Good. So they're the outside part of the atom where the electrons are located. Yeah? Is the outside part of the atom where the electrons are. We named it and described it. That will get you all 10 points. Okay? Now, that question is worth 10 points on the test. That's a lot of points. Okay? So make sure you know it and go through it slowly, just like that, or in any other way, to make sure you hit all 10 points. Now, let me ask you this. What if you wanted to name all the 5 parts and then go back through and describe them? Could you do that? What if you wanted to say the 5 parts are the proton, neutron, electron, nucleus, and shell? The proton is the positive particle in the nucleus. The neutron is the neutral particle in the nucleus, etc. Would that be okay?
Yeah.
Yes. As long as you're naming all 5 parts and describing them accurately and correctly, then you'll get all the points. Okay? Landon, question?
And when you said that you a lot of points, really good because it's you get every single person but then
Exactly. Yep, it's a big chunk of the test. Okay? So be good, be careful with it. Ethan A. No. Mm-mm. Nope. It doesn't have to be in this order. It can be in any order you want as long as you have all the parts. Ethan H.
Could I list proton, electron, nucleus, neutron, shell, electron, and then put proton below it and then start describing them?
As long as it's not like a run-on sentence. Okay? And fact, at that point, I would just put a period. Okay? All right. Go on to the back. The back part is a bonus section. It's not necessarily going to be bonus in the test, but this part's kind of fun. This is where you get to kind of apply what we've been learning. Okay? So, number 1 on the back. I'll change the slide in just a minute. If you're still writing, that's fine. What is the special name for group 18? So group 18, that outer edge all the way down. What is the special name for that category or that group? Noah? The noble gases. Good. Then it says to list all the elements in that group. Noah, can you tell us all the elements in that group?
Helium,
Very good. Helium. I'm gonna change. Don't worry.
So are we writing?
I'm just writing the symbols.
We're writing the name, the
Okay.
name of the group and the.
Are you good, Nathan?
So we're writing.
So this.
the gases.
Noble gases. Then we're listing all the names. Helium, neon, argon, krypton, xenon, radon, and oganescent.
You know that like Christian elements book you had?
Uh-huh.
I have that same book, but they haven't like improved it to where they have the new elements that we discovered. They only have the 116, even though they know there's 118.
Interesting. All right, number 2. I've given you the chemical formula. You need to go back and list which elements are in these compounds. So, kind of like this is the recipe. I want you to tell me what the ingredients are. Now, keep in mind that this would actually look like H2SO2. Okay? The numbers are usually subscripts. So, someone tell me, what are the elements involved in this quote-unquote recipe? Bella? Not helium. Helium is He. Hydrogen. How many atoms of hydrogen, Bella? Good. 2 atoms of hydrogen. Then what? Well, if it's a capital letter, then these are both separate symbols. Capital S, capital O. So what does capital S stand for? Sulfur. How many atoms of sulfur, Bella? Is there a 2 after the S here? So it's not 2. How many? If it were 0, it wouldn't be in the recipe at all. 1. Very good. If there's no number after the symbol, that means there's just 1 of that atom. Okay? And then the last one, Bella? Good. And how many atoms of oxygen? Very good. 2 atoms of oxygen. Okay? The next one, CO2. Connor?
C is for carbon, we have 1 and red line.
Yeah.
And O is for oxygen, we put 2.
Good. 1 atom of carbon, 2 atoms of oxygen. Okay, letter C. Ethan H.
It's 2 atoms of hydrogen and 2 atoms of oxygen.
Good. 2 atoms of hydrogen and 2 atoms of oxygen. This would be hydrogen peroxide. In case you're curious. Anna, you with me? And letter D. Reagan?
There is 1 atom of copper.
Good.
And there is 1 atom of sulfur.
Mm-hmm.
And finally, there's 4 atoms of oxygen.
Good.
But also, I have a comment on hydrogen, sulfur, and oxygen.
Okay.
I'm pretty sure that, maybe not, maybe it's just one of all of them. But I'm pretty sure that's supposed to be sulfuric acid.
I don't think so. It's supposed to be copper sulfate.
No, on the top one.
Right. It's the same thing. Copper sulfate.
No, all the way up.
This one?
Yes.
Oh, that I don't know. Maybe.
It might be sulfuric acid, but I'm pretty sure they only have one atom.
Oh, interesting. All right, and then 39. This one's fun too. Determine the elements that make up these compounds. Then use the names of the elements to figure out the name of the compound. Place the letter of the symbol of the compound in the blank next to its name. So, O2. Okay? Which of these is probably the name for this compound? We know O2 has to have oxygen in it, so which of these would be its name? Ethan A? Good. Oxygen gas. Now, of the two that are left, B and C, which of them do you think is iron oxide? Landon? Why do you think it's B? Good, because Cu is copper. And actually, Fe is the symbol for iron. Okay? This is iron oxide, which means that C is copper sulfate, which makes sense because Cu is the symbol for copper. Okay? All right. Now, last thing I'm going to tell you is this. Let me ask you a question, actually. Let's see if you remember. Do you have to memorize this? No. When I give you the test on Tuesday, I will also give you a copy of this. Okay? Now, this is the exact same table as the one you have in your notes, but it's not going to have the colorings or the groupings. You don't have to know the groupings. You don't have to know the lanthanides and the halogens and the transition metals, but you will use this to fill out questions like we have in that study guide. Okay? I can't remember, but you may have to tell me whether or not an atom is a metal, non-metal, or metalloid based on where it is on the table. Okay? So if it's all the way over here, you know it'll be a metal. If it's all the way over here, you know it's going to be a non-metal. Does that make sense? Noah?
We have to know all the numbers.
No, you don't. No, this part's bonus. That part was bonus in the back. You don't have to memorize that either. And also, you may want to know, I can't remember if it's on the test or not, but you would want to know that these are all noble gases. Because you'll have this to use on the test.
Have you heard of the periodic table song?
I know there are many of them. I don't think I've ever actually watched the video.
I've
or
watched the
listened to
one,
them.
Hydrogen and lithium, ion. It's like
Goes all the way through.
yeah, it goes like
Man.
it's that I don't know what it's called, but it's dun.
Ooh, I don't know either, but I know what you're talking about. Okay? All right, so what we're going to do now is the periodic table practice. All right? This is the part that if you don't finish, you're going to finish for homework. Okay? Except for online kids, obviously, they'll finish it at the same time. But it's the exact same thing, except these are actually a little bit harder. I picked more obscure or not as familiar elements. Okay? Things like bismuth or niobium, francium. I will say, though, there are two typos on this. Not typos, but just things to fix. One is a typo. For cesium here, any question two? This is misspelled. There should not be an A here. Okay? Cesium with a CE. And then, on question number 3. This one, when I made this, I think we still had the old charts. So ununtrium is number 113. But on your chart, I think it actually has a name. Okay? Yep. Sweet. Okay? All right, so I will pass this out for you to work on.